Okay, Mod 2, Lesson 10. We're going to be multiplying decimals against multi-digit numbers. Okay, so our first problem, we have 2 1/10 times 82. And the first thing we do is we're going to do estimate. In order to estimate with a decimal, we're going to get rid of the decimal. So 2 1/10 would be close to the closest whole number, which would be 2. 82 is the closest tens, so that would be 80. So we know our answer has to be close to 160. Now, we're going to go ahead and draw an area model to solve this one. And on top, I'm going to put 21 tenths, because I renamed it from 2 1/10 to 21 tenths. And now, we're going to split up using a distributive property, 80 in 2, and 2 times 1 would be 2, 2 times 2 would be 4, so I'm going to end up with 42 tenths. Now on the 80, I'm going to take out that 10. Now I'm going to go 8 times 1 is 8, 8 times 2 is 16, and that's 1,680 tenths. When I add them together, tenths and tenths, I'm going to get tenths. When I add 2 and 0, I get 2, 4 and 8 is 12, carry our 1, 6 and 1 is 7, and our 1. So we end up with 1,722 tenths. Now we know our answer has to be close to 160. So the only reasonable place to put the decimal place to be close to 160 would be between the two 2's. So we have 172 and 2 tenths. Let's look what the standard algorithm look like this. 2 times 1 would be 2. 2 times 2 would be 4. That's 42 tenths. Notice the same thing we had in our area model. Now we're going to take the 0 out of the 80, and we're going 8 times 1 is 8. 8 times 2 is 16. That's also tenths. When we add them up, that's 12, carry 1, 7, 17, 22 tenths. Now over here, we place our decimal plate by the estimate. Now over here, I know that 2 has to go in the tenths place. So on the next one, first thing we're going to do is our estimate, and 4 2/10 is closer to 4. 34 would be closer to 30. 4 times 3 is 12, and put our 0. So we know our answer has to be close to 120. So I'm going to go ahead and draw a quick area model. And I'll put my uniform on top, which we can see 4 2/10 would be 42 tenths. And then I'm going to take and split up my 34. Now allows me to go 4 times 2 is 8, 4 times 4 is 16, but it's not 168, it's 168 tenths, because I multiplied ones times tenths. Now on the next one, we're at 30, so I'm going to go ahead and put the 0 in there. 3 times 2 is 6, 3 times 4 is 12. That is also tenths, because ones times tenths equals tenths. 8 plus 0 is 8, 6 plus 6 is 12, carry our 1, giving us 4. And our 1. So we end up 1,428 tenths. Now we know our answer had to be close to 120. So the only reasonable place to put it would be after the 2 and 8. Now let's see what the standard algorithm looked like. So I'm going to come over here, 42 tenths times 34. 4 times 2 is 8. 4 times 4 is 16. So that'd be 168 tenths, same as our partial product. Now we're going to put our 0. 3 times 2 is 6. 3 times 4 is 12. That is also tenths. So we're going to add them both together, and we're going to get tenths. 8 and 0 is 8. 6 and 2 is 12. Carry 1, 4. And once again, we got 1,428 tenths. And this time, though, I know the 8 goes in the tenth spot, so 142 and 8 tenths. On B, we're rounding again to find out what approximately should be. 65 would be closer to 70. 5 and 8 tenths would be close to 6. 6 times 7 is 42, and we add our 0, so we know it's going to be close to 420. Now I'm going to do another area model. And on top, we're putting our 58 tenths. And we're splitting up the model to 60 and 5. 5 times 8 is 40. Carry our 4. 5 times 5 is 25. And 4 would be 29. So that's going to be 290 tenths. Now next one, we're going to take our 0 out, and 6 times 8 would be 48. Carry our 4. 6 times 5 is 30, and 4 would be 34. And once again, that's 34 tenths. Now when we add them together, we're going to end up with tenths. And 0 plus 0 is 0. 8 plus 9 is 17. Carry 1. 2 and 4 is 6, and 1 is 7, and 3. So we have 3,770 tenths. Our estimate was 420. So we know that it has to be 377. Now let's do the standard algorithm real quick. We have 58 tenths and 65. 8 times 5 is 40. 5 times 5 is 25, and 4 would be 29. And that was tenths. And that matches. Now we're going to put our placeholder over here. We got 6 times 8 is 48. Carry our 4. 6 times 5 is 30, and 4 would be 34. That is also tenths. 0 plus 0 is 0. 8 plus 9 is 17. Carry 1 will be 7. Once again, 3,770 tenths. And with that, we know the 0 goes in the tenth spot, so it would be 377 would be our answer. Okay, now on these, we're just going to be using the standard algorithm in order to solve. So first thing we're going to do is round. We know 3 and 3/10 is close to 3. 16 would be close to 20, so our answer has to be close to 60. So I'm going to rename 3 and 3/10 to 33/10 times 16. 6 times 3 is 18. Carry our 1. 6 times 3 is 18, and 1 is 19. That's 198 tenths. Should be tenths up here too, not tens. Now on the bottom, we're going to put a 0 because we're multiplied 10. 1 times 3 is 3. 1 times 3 is 3. And that is also tenths. We add them together. That's 8, 12, 500, because we carried our 1, 528 tenths. Now we know it has to be close to 60, so we know that has to equal 52 and 8 tenths. Come on our next one. Well, 15 is closer to 20 because we're going to the nearest largest digit, which is the tens place. 17 would be close to 20. 2 times 2 is 4, and 2 is 0, so we know our answer has to be close to 400. So now we're having 156 tenths. We're going to multiply that by 17, and I did it that way so I don't have two partial products. 7 times 2 is 42. 7 times 6 is 42, carry the 4. 7 times 5 is 35, and 4 is 39. 7 times 1 is 7, and 3 is 10. And that's 1,092 tenths. And now we're going to go with our 10, but we're going to put our placeholder 0, and 1 times 6 is 6, 1 times 5 is 5, 1 times 1 is 1. And that is also tenths. So when we add them up, we have 2, 15, carry 1, 6, and 2,652 tenths. Now, in order to look at our estimate, it says 400. So the closest estimate to get that estimate would be putting the place value of the decimal point between the 5 and 2 for 265 and 2 tenths. Now that does seem like a large difference between the two, but if you remember, we rounded up 15 to 20. So it is going to be less than that number. Our next one, 73 is close to 70. 2.4 is close to 2. 2 times 7 is 14 was 0, so it should be close to 140. So now we're going to go, and I like keeping it on top, so I'm going to do 24 tenths times 73. You could do the other way. I just like keeping my unit form on top. 4 times 3 is 12. Carry 1. 3 times 2 is 6. 1 is 7. So that would be 72 tenths. Put our placeholder. 7 times 4 is 28. 7 times 2 is 14, and 2 would be 16. That's tenths. When we add them up, 15, 7, because we had to carry our 1, 1,752 tenths. Which if in order to place our decimal point, since our estimate was 140, it'd be closest 175 and 2 tenths. Now this is another one we rounded down. So since we rounded both of them down, we know the actual number would be more than ours. So it's reasonable. On the next one, 193 is going to be closer to 200. 57 is going to be closer to 60. 6 times 2 is 12 with 3 zeros. So we should be getting close to 12,000 on this one. So on this one, I'm going to put 1,935 tenths. And I'm going to multiply that times 57. Now 7 times 5 is 35. 7 times 3 is 21 and 3 is 24. 7 times 9 is 63 and 2 is 65. 7 times 1 is 7 and 6 is 13. So that's 13,545 tenths. To put our placeholder, 5 times 5 is 25. Carry our 2. 5 times 3 is 15 and 2 is 17. We're going to carry our 1. 5 times 9 is 45. 1 is 46. Carry our 4. And 5 times 1 is 5 and 4 is 9. Now there's also tenths. So our answer will be in tenths. So 5, 9, and that'd be 12 carry 1, 9, 10 carry 1, and 11. So we got a pretty large number here. We got 110,295 tenths. And we know our answer has to be close to 12,000. So we know that in order for this to be close to 12,000, it's going to have to be, if I put my whole number up here so we can see it, in order to be close to 12,000, we wanted it at 11,000. So I'm going to put it here. So now we got 11,029 and 5 tenths. Mr. Jansen is building an ice rink in his backyard that will measure 8.4 meters by 22 meters. What is the area of the rink? Well, if you think of it as area is like so. And it says 8.4 meters, so it'll be 84 tenths in meters. And then it'll be 20 meters by 2 meters. So 2 times 84, 2 times 4 is 8, 2 times 8 is 16, and that's tenths. We put our placeholder in there. 2 times 4 would be 8, 2 times 8 would be 16. That isn't tenths. We add them up. We end up with 8, 14, carry our 1. That's going to be 1848 tenths. Now we need to do an estimate here. So with 8.4 times 22, we know that'd be close to 8 times 22 would be 20, which means 160. So it'd be close to 160 meters. So in order for this to be close to 160 meters, it's going to have to be 184.8 meters. Okay, Rachel runs 3.2 miles each weekday and 1.5 miles each day of the weekend. How many miles will you run in 6 weeks? Well, let's start off with a tape diagram. Let's label everything we know. Well, it says Rachel runs 3.2 miles each weekday. We know there's 5 days in the week, in weekdays. So I'm going to put 3.2 miles, and that's 5 days a week. And what that shows us that if we want to find that total, that's going to be 3.2 times 5. And then it says 1.5 miles each day of the weekend. Well, there's 2 days in the weekend. So we know this is going to be 1.5 and 1.5 because this here is our weekend. And this is our week days. So now in order to find this, we know it's 1.5 plus 1.5 to add those two together. And 1.5 plus 1.5, 5 plus 5 is 10, carry 1 and 3 with our decimal. So that's going to equal 3. So now 3.2 times 5. First thing, let's do an estimate. We know that'd be closer to 3 times 5, so it'd be close. Answer is going to be close to 15. So now we got 32, and I'll rename that as tenths times 5. And 5 times 2 would be 10, 3 times 5 would be 15, and 1 is 16. So that's 160 tenths. Now, I know our estimate was 15, so it has to be close to 16. Now, so that was during the weekdays, she runs a total of 16 miles. And during the weekend, she runs 3 miles. So for the whole week now, if I add those two together, that's going to be 19 miles. But they want to know how much she run in 6 weeks. So now I got 19 miles times 6. 6 times 9 is 54. 6 times 1 is 6, and 5 would be 11. So she would run 114 miles a week.